What page is this in your notes? Page 20. Go ahead and open it up. We're not going to do the top example, but I do want you to fill this in. We're going to continue working with our slope fields. So, a couple things to keep in mind. Let the places where the slope is 0 and undefined help you out. Usually, I would say 90% of the time, just that is enough to sort out the multiple choice. If it's not, I'll give you some other ways to tackle it, but usually you can just pick them apart by knowing where the derivative is 0 or undefined. So let's go take a look. On this one, the derivative will equal 0, or you'll have horizontal tangent lines everywhere where y is equal to x. So like at 2, 2, 3, 3, 4, 4, along that diagonal line where y is equal to x. So you search the slope fields to find the one that has horizontal tangent lines along that diagonal. So which one is it? You can kind of clearly see. Who is it? Help me out. Which one's stepping up along y equals x with horizontal or flat tan lines? Who is it? B. Yeah, it's this one. Everywhere along the y equals x, we've got these little flat stair stepping right here, right here, right here. This one looks like it has a slope of 1 there, which would indicate I'm probably either this one or this one. You know what I mean? You can kind of pick them apart. But let's just go one by one. With number 2, again, this is going to have a slope of 0 anywhere x is 0 or y is 0. So I'm going to have horizontal tan lines on the x-axis and on the y-axis, which means it's for sure isn't C, right? Because that's got verticals. It's either D or it's A. So which one seems like it's got slopes going to 0 on both the x and the y-axis? Which one looks better? D. Yeah, you can see it. This one looks like it's going vertical on the x-axis. So that one's D. All right, this one right here, it's going to have horizontals anywhere x is equal to 0, which would be on the y-axis. So it's got to be which one? Either, who do I have left? I have C and A left. Which one's got horizontals on the y-axis? A. Yeah, you can see it. So if you just use those zeros and infinities, that's usually enough to get it for you. On the flip side, though, sometimes they give you the graphs and match the general solution. So keep in mind, these are giving you the derivative, so we're trying to match tangent lines. This one right here is the original function. So what you're trying to do is squint and go with the flow. Sometimes it even helps to kind of draw in here. What does this one look like of all of these? You should be debating between 2 of them, right? It's either what? Cosine or sine? Well, it's going through 0, 0. This is where it's sending you, right? So it's got to be sine. Yeah, nice and straightforward. This one here, if you squint and go with the flow, it's like kind of, you just drop the feather and it's like, oh, yeah, somebody just said it. They said it's cubic. So who does it have to be? This one. Right, and I'm done. By the way, this one's would look slope field, if you went with the flow, would kind of look like that volcano graph. This one would be heading like this. This one would have, you could see it. So nice and easy. I want you to take a minute. I'm going to pause this, and I want you to go match those 6 with the correct slope fields on this one. So there's several ways to approach these too. You can match the graph with the derivative equation, or the reverse. You can look at symmetry. For example, this one only has x in it, so I know I'm going to have vertical symmetry, right? So it's going to run the sames all the way down. There's so much stuff you can do with them. Sine's derivative is a cosine, so it's going to be the wavy one. They're pretty workable. Actually, just starting with that, who does this one have to be? Yeah, that one's D. And again, if I were to go with the flow, this one's going to kind of go up, down like this. But when this one you could actually solve even. If you have one you can solve. If you were to separate and integrate, you'd be integrating sine x. What's the antiderivative of sine? And again, I'm giving you a negative cosine, and that's exactly what this graph looks like. So they look good. I saw Rachel for this one chose the exact first one right off the bat. That's obviously the e to the x. It's the only function whose derivative is itself, and so it looks like its derivative graph, which is great. So this one was f. Where's another easy one? I think I saw you do this one right away, because he saw, oh, this is 0 when y is 2. Bingo, it just stood out. So, I mean, it's weird. I was walking around, and you all picked different ones, but correctly and for really good reasons. So this one's the next easiest one right here, because that has to have vertical symmetry. Plus, I know that if its derivative was linear, what was the original? Yeah, parabolic. The only one that looks like a parabola is A, so that one fell out nicely. This one's nice and easy with the subtraction because it's 0 anywhere where y is x. So it's going to, again, I'm using all kinds of different thought processes for these, but they're all working for me, so I'm going to do that one. That leaves for this one, which one is it? C. Yep. Anyone get all of those right? We're going to skip this because I think that's easy. So the next thing what I'm going to do is have you go into your homework packet, and we are going to do number 17 together. But before we do, I want you to make the slope field for it. So go to your homework packet, number 17, just make the slope field, and then we'll do the rest of it. And then what I'm going to have you do is I'm going to give you 10 minutes to do number 18, and you're going to score it like an AP FRQ. But 17, just do the slope field in your homework packet. What page is that in your homework packet for people listening? What page is on the bottom? 9. So page 9 in the yellow homework packet, we're going to kill off 17 together, but I want you to make the slope field on your own. So I'm going to pause this while you make a slope field. So your slope field should look like that. Loosely. College Board would usually grade it. They'll give you 1 for getting all the zeros in the right spot, and then another for everything kind of relative to that. So yours should be similar. I also made a table for those of you who like to make the table. It does kind of, if you lay that all out, then you can, it's where you want to spend your time. You know what I mean? So the next thing we're going to do is do the rest of it together. So for part B on that one, it says, let f be the function that satisfies the given differential equation. Write an equation of the tangent line. So what 2 things do I need? Give me one of them, Tyler. Equation of a tangent line. I need a slope and I need a point. They handed me the point. They said through 1, 1. So here's my point. All I need to do is find the slope of that point. So I need dy dx at 1, 1. Once I have that, I can write the equation for the tangent line to that curve. So at 1, 1, what's the slope of the tangent line? Just go plug them in. Says it's xy over 2, so I've got a nice slope of a half, or if you already made the table, it's just sitting there. So here's my tangent line equation. Y minus the y I know is equal to the slope there times x minus the x I know. Done. Full credit. That was an easy question. And then it said use this to estimate what f of 1.2 would be. Now I want you to go back up here so you can see graphically what you're doing. We're now talking about right here at this dot at 1, 1. The curve I could kind of draw like by dropping that feather and going with the flow. It's going to kind of go like that. But what I'm doing right now is I just found the equation of that green line. I'm going to use it to estimate what happens just a little bit over at 1.2. So I'm going to plug 1.2 into my line. So I'm going to go like that. I'm going to say f of 1.2 is going to equal 1/2 of 1.2 minus 1. I'm just going to go plug it in, and then I'm going to add that 1 over. That's my linear approximation. I actually should put the squiggles on that one. And then I want to have a calculator. So I've got 0.2. I've got 1/2 of 0.2 is 0.1. And then I add it. I'm at about 1.1. Back up to the graph. Go put this on here so you know what you just found. You're saying that on the line, it's 1.1. Is it going to be the exact same thing as where it is on the curve? Do you think we're going to be an under or overestimate? You can see it, right? Is this red dot going to be an under or an overestimate? It's going to be a little bit under. So now for part C, it says now go solve it. Like I don't want you to use a line to approximate it. I want an equation for that function. So it says find the particular solution. So here's what we've got. Here's our derivative. Now this is where the chunkier points come from because that's all kind of easy. This is where you gain a huge chunk of points, but you have to know how to start. How do I start solving this and actually figuring out what y is? Separate. Exactly. So we're going to separate. We're going to get our y's over here. 1 over y dy is equal to x over 2 dx. Once I've separated, Sammy N, what do I do? I what? Integrate or anti-differentiate will work. Okay, Colin, what's the antiderivative of 1 over y dy? Awesome, you guys are really good at this. Ln, absolute value of y. John, what's the antiderivative of x halves? X squared over what? Over 4, yep. And then We've got Carl over here. And then next up, how about Cam? How do I undo the ln? E to the, yeah, I'm going to e to the ln y over here, and I'm keeping the absolute value intact. E to the x squared over 4 plus c. I'm showing all my work just because. Sammy D, do you remember how we took care of this situation over here last week? I do. Exactly. I'm going to disengage that c from the exponent, but remember it doesn't become this plus c. I'm going to write that side as e to the x squared over 4 times e to the c, and you can do that in your head if you want. This is still absolute value of y, right? And we did that so we could call this whole chunk of stuff just what, Jack? Good morning, Jack. What's e to the c? Yeah. Is a bigger C. See, he can think on his feet. So now we've got y is equal to bigger C, e to the x squared over 4. All right, so I can send this through 1, 1 and find the exact Carl. So now we're going to go do that. You can see why this gives you the majority of your points. So let's go up here, and a 1, I like to indent. I have to get a 1 when I do C, e to the 1/4. And unfortunately, this is where people start to screw up. Matt P, how do I solve that for C? Wow, you need to. How do you solve it for C? This is a constant. Thank you. Divided by e to the 1/4, or you could even just see to multiply to get to be 1, it'd have to be e to the 0. So you need e to the negative 1/4 if you want to use common sense. You don't get points for the manipulation. So, but yes, you would divide. So here's my C, Matt P. Are you ready? Say yes. Say yes, ma'am. Alrighty, here we go. So I've got y equals to, I'm outdinning, e to the negative 1/4, Timothy, times e to the x squared over 4. Is that right, Timothy? Yes. That's not how you would see it on the key, but you would get full credit for that. I'm going to make it look a little nicer. I'm going to call it e to the x squared over 4, what? Minus 1/4, or even like that. Is that legal? It's all good stuff. It doesn't matter. This is the exact curve. So I approximated with a line. Now I solved it exactly. And it says, now find the exact value at 1.2. So you would just go plug a 1.2 in here, and you would have a calculator, and you do it exactly. And you're going to do that for me, Trevor. Thank you. So we're going to hold off on that for just a second. He's going to give it to us on that. But let's go to part D and E are kind of the same. It's going to say, how does it compare? Whatever he gives me, I know that my 1.1 that I got with the line is going to be less than this because I could see my line underneath the curve, right, Ihan? Remember that way back when I did, come on, when I drew this, I could see that my tan line was under, right? So he's going to give me a number that's more accurate, right? What is it, Trev? 1 point? All right, so I am slightly under, but I can't, it says justify. What reason do you have to think that, well, right, underestimate. Our tangent line was an underestimate, but that's a 50-50 guess. So what reasoning, what math reason do you think is why my tangent line provided me with things that were just a little under? There it is. It's because it's concave up there. Let's write since y is con up at 1, 1. You can see it from the graph. You don't need to find a second derivative. So now what I'm going to do is give you 10 minutes to go do number 18, and then you're going to score yours out of 9, like the College Board would score it. So take a minute, go do number. So on the first point you would get is basically just for the slope field. So if your slope field looks like this, right, +1. Again, it doesn't have to be perfect. Normally they'll run a check that you did horizontals, verticals, and give you a point. For that one, they also ask for the general through 0, 1. So for this top graph right here, if you've got that going, give yourself another 1. So +1 for the slopes, +1 for the solution right there. And then a huge chunk of points for the next part of it. In part C, you are supposed to solve it. It's not the equation of a tangent line or anything. It is solving this differential equation. So here's how the points would go. You would get 1 for separating. So if you separated, give yourself +1. Okay, the next thing you'd get a point for is the antiderivatives. So if you wrote y squared over 2 equals x squared over 2 plus c, you'll get another point. This whole top chunk is worth 3. So one for the separating. Sometimes they give you two, one for the left and one for the right, but because it's the same antiderivative, you would only get one for that. But had this been like an e and you had to do e to the x, then they'll put that as 2. But that would just be 1. The next is for finding Carl. So you should have had a plus c on there. You should have gone and found him at any point. It doesn't matter if you wait. Some of you waited to the end. I did it right here. It doesn't matter. But you should have ended up with, regardless of where you did it, Carl being 1. Okay, so you've got 1 for the antiderivative, separating, 1 for the antiderivative, 1 for including Carl, and then you get 1 for finding Carl. Are you good with how it's scored? And then at the end, you're going to get 1 more for choosing whether it's the positive or the negative of these two. So if you forgot to put plus or minus, you'll be okay for this first part because it is positive. But how do you know for sure that this one, the answer to part C, had to be positive? Yeah, the 0 has to spit out a 1. And you can see it up in the graph that the y's are all positive. You can see it, right? So the graph kind of helps with that. Then for the next point, it was just on the graph doing the solution through, what was it, 0, -1, I think, right? I don't know why this won't scroll. Here we go. No, that's not doing it either for me. There we go. Anyway, so another point, if you did the other solution, it was going through 0, -1, so basically the same thing. And then the 9th point is when you put in a 0, you wouldn't have to resolve. It's this exact same thing, but when you're at 0 and it spits out a -1, you'd need the minus. So that would have been scored out of 9. Anyone get 9 out of 9? Oh, a whole chunk of you. How many of you were over 4 out of 9 who had enough time to finish? Good. National average again runs between, this one usually between 3 and 4, most between 2 and 4, but this one's got some kind of some easy parts to it. So next up, I told you we're bouncing all over. That was in the homework packet. We're going to go back one and do one more in the notes, and then I'm going to have you do one in the homework packet. So back to the notes. We're going to do the bird problem here. And I am going to stop recording